Hello, Earthlings! Are you afraid of worms? If you calmly feed them to the fish in the aquarium or you string it on a fishing rod, then you most likely don't have wormophobia. But if you feel panic at the sight of a worm, you start to feel sick, or you refuse to go to nature because you can't meet worms there, then you probably have already watched this video. Just kidding. There will be no disgusting worms in this video. I left them for the next one. Nevertheless, I think there are not so many people who are touched by worms or feel complete indifference to them. Most of us still have some aversion to all sorts of worms. And it's very interesting, because worms are as harmless as possible. In general, the fear of worms is very well combined with various other phobias and anxiety. Like many other phobias, the fear of worms is treated by cognitive restructuring. That is, by replacing old beliefs with new ones. Usually, of course, this is more objective view of your fear. As they say, knowledge is the antidote to fear. And I think that for those who have some problems with worms, this video can help. Although it may be the other way around. So if sometimes you squeeze your eyes a little, write in the comments. Maybe worms are really worth being afraid of. That's what we'll find out. To begin with, who are worms in general? Spoiler: not everything that we think is a worm is actually a worm. Look, for example, at this pal. No, not like that. Look at this tree. What do you think it is? You got it right. These holes were chewed through by our friend in the wood. The question immediately arises: what kind of jaws should this monster have? But about everything in order. To begin with, it's called a shipworm. I think its name speaks for itself. And in length, such worms, depending on the species, reach more than 1 meter. Well, accordingly, they dig tunnels to fit their size, up to 2 meters in length and up to 5 centimeters in diameter. For crushing wood, they have a special tool in front, such a jagged shell. At the back end of the shipworms are 2 siphons. If the worm is alarmed, it removes the siphons and blocks the entrance to the tunnel with plates that are nearby. Siphons, if anything, are such tubes that are used by mollusks for breathing, nutrition and so on. Yes, you heard right, I said mollusks. Because a shipworm is actually not a worm at all, but a mollusk. That's why they only eat wood that is in salt water. So theoretically speaking, if you sailed to explore a sunken ship, get ready to meet shipworms. Well, if you were a Filipino, you would probably be happy about it, because these worms are food for them. Yummy! The guys go to the mangrove forests and specifically hunt these mollusk worms. More than that, they are specially bred for this. Which is actually not difficult. After all, shipworms are not picky creatures. They just need water and wood. Cellulose is certainly difficult to digest, so not many creatures feed on it. But here the bacteria with which the worms live in symbiosis help. So, previously these shipworms caused a lot of trouble to people. As I have already said, as you understand from the name, they chewed through the ships. You are sailing on a ship, you haven't crossed paths with an iceberg, but for some reason you're starting to sink anyway. And it turns out that you just have a ship full of holes. Well, or they chewed through the dams unnoticed for years, eventually causing a collapse. For example, such a case was in the Netherlands in the 18th century. However, mankind can benefit from everything. We take almost everything from nature. I will often talk about that. Here is another example for you. For Marc Brunel, an engineer of the 19th century, this shipworm became a source of inspiration. He was trying to figure out how such a soft worm avoids the enormous pressure that arises from the swelling of wood in this tunnel. It turned out that the mollusk processes the walls with something like cement. When it dries, it becomes very strong and doesn't not allow the wood to shrink, what is used in the construction of tunnels. Plus, their head is covered with a hard shell, which is needed not only to drill, but also to keep pressure in the not yet frozen part of the tunnel. And according to a similar scheme, Mark Brunel came up with a tunneling shield for the safe laying of tunnels, so that the loose soil does not collapse. With the help of it, the first tunnel was laid under the Thames, and it's still used in the construction of the subway, for example. So if you watch this video somewhere underground, you can imagine that you are rushing in a big worm. But I'm stuck on these clam worms. Here is another example for you. Do you think it's a worm attached to a snail? No, it's just the proboscis of this snail, Kellettia kelleti. It can be found in the coastal waters of California and Mexico. This snail is a scavenger, and that's why it needs such a proboscis. Apparently, natural slowness has brought you so far until you reach the prey, someone will already drag it away. And nature is like this. Hold it. And now these snails have a proboscis. And maybe the opposite situation. Looking at this, I'm sure that most people would think that this is some kind of another strange algae, like reefs or corals or what is it normally called. But actually, these are not mollusks or someone's proboscis. It is really worms. These guys are called Riftias or giant tube worm. They belong to the class of polychaete worms. Thanks to the bristles, they can stay in these white tubes. They may seem small, but in fact adults reach up to 3 meters in length together with tubes. This little red part of them is just the tip of the iceberg. The rifts live at the bottom of the Pacific Ocean. Also of interest is the structure of their body. The body is enclosed in a chitinous white tube. Moreover, the tube is not a part of the body, but is built by them separately. Again, it is secreted by glands and hardens cemented. But the main thing is the way of nutrition. Most of the body is filled with a trophosome, something like an intestine, but it has no entrance or exit. In general, the larvae of these giant tube worms with the digestive system are all as we are used to. They have both a mouth and an excretory system. They live and move freely. But as they mature, they attach to the bottom and sew up all the holes for themselves. The fact is that giant tube worms always live near some hydrothermal source. Firstly, it's warm there, and secondly, there is hydrogen sulfide, nitrogen, oxygen and carbon. Worms themselves, in fact, like most normal animals, cannot feed on such simple molecules. But the trick is that when Riftia are in the state of larva, they get special bacteria with which they symbiote in the intestine. Together with hemoglobin, hydrogen sulfide and others enter the trophosome, and there the symbiotic bacteria process simple molecules into complex organic substances, which are already absorbed by giant tube worms by the intestines. On this, in fact, the digestive system is built. The process is called chemosynthesis. The principle is essentially the same as that of photosynthesis, only the energy of giant tube worms is obtained not from sunlight but from chemicals. Therefore, if the hydrothermal source stops working, then the colony of giant tube worms dies. Worms absorb the necessary molecules through these red processes. They contain blood vessels. Just because of the presence of hemoglobin in them, they are red. When the worm is scared, it pulls its plum into the tube that you've probably seen somewhere in movies or cartoons. There are actually a lot of organisms similar to giant tube worms. All of them belong to the Pogonophore family. For example, I can say they're brothers, but their houses are slightly different, with segments because of which they can bend. Why this is necessary is not entirely clear, since their digestive system is the same. Or these beauties here. This is Bispira brunea. They live in the Bahamas or the Caribbean. A beautiful worm, a beautiful place. They also settle in tubes that are attached to some coral and live in colonies. In general, these worms, besides being beautiful, are also sensitive. From the slightest vibrations, they hide in their tubes. Also, if one person hit, the whole colony reacts and hides after him. Unlike the same giant tube worms, they have a mouth and through it they feed, for example on plankton. But if you look on anemones, are not worms, although somebody might also think so. We have looked at unusual mollusks, which it turned out are not worms at all, and at the strange sea outgrowth, which as it turned out are just the same, worms. So who are the worms anyway? The one who first brought worms into a separate type of animal was Carl Linnaeus, and he included all invertebrates with the exception of arthropods. Well, according to this logic, sponges, jellyfish, sea anemones and many others, and even tardigrades, all would be worms. Therefore, at the end of the 18th century, this class of worms was cancelled. And since then, worms have been divided into three types: flat, round and ringed. Some have an additional layer, others receive an anal opening, and others have a closed circulatory system. But that's not the point. The bottom line is that worms as some kind of term does not exist. This came out to us in the collective image, but we might as well say a living tube without bones. Worms are very different even within their type. At the moment, 50–70,000 species have been studied in total, each of which has its own complex evolutionary path. We'll get to the usual earthworms, which are actually annelid worms, but for now I want to show you other unusual, interesting and somewhat frightening specimens. Since we have just sorted out the rift, let's continue the topic: the strange nutrition of worms. This handsome man, for example, belongs to the type of flatworms. However, looking at him, you will not immediately understand that he is a worm. The way he moves and the way he looks more like a snake. Besides, confuses a strange head, like a hammerhead shark. Well, in general, it is called a hammerhead worm. Their cunning lies in the fact that they are predators. They behave aggressively when hunting. They react instantly to the appearance of victim, then they chase it and sharply attack. During the attack, they stick to it, so the victim literally sticks to them and cannot out it anyway. With his mouth, which is on his stomach, he secretes enzymes that literally digest the victim to which the worm has stuck, and then he gradually sucks up the digested. They hunt snails, mollusks and other worms, including on their own. In places where hammerhead worms have been introduced relatively recently, they pose a threat to farmers. For example, the same earthworms in that area did not develop a reflex on them. They don't really crawl away when hammerhead are nearby. And without earthworms, the soil becomes less fertile. The problem is that the hammerworm is not so easy to get rid of. It has the ability to regenerate. Moreover, their reproduction happens exactly like this. This is called asexual fragmentation. That is, an individual is divided into several parts, and they form new separate organisms. The same hammerheads grow up, plus in a classic sexual way they can too. Therefore, when returning from the southern countries, be careful whether you have brought any slug with you. Although initially they were common in the tropics and subtropics, but now they can be found in a larger area. For example, in the USA, in Europe they already exist, in France for example. And the idea of feeding this monster you could see in an old movie about Godzilla. Outwardly it resembles an earthworm, only the size gives out that something is wrong. And it grows up to half a meter. It's a giant red leech. The habitat is small. This is Mount Kinabalu on the island of Borneo in Malaysia. By the way, a giant earthworm also lived there, but it is already grey, and he is very afraid of giant red leech, even though it's about the same size. And that's why we are used to leeches sticking to something and drinking blood. However, this leech doesn't stick, it swallows the victim whole. And this poor earthworm seems to be her favorite dish. Tracks down the slimy trail, and when he finds it, he swallows it. At this moment, it looks very much like an anaconda. By the way, it takes about a month to digest the victim. Well, since I mentioned the leeches, they are actually the most worms. Treatment with the leeches or Hiruda therapy is well known to you, and I want to say that this is useless activity. The fact is that it came from the idea of bloodletting. In the days of Hippocrates and Galen, excess blood was considered the cause of a lot of diseases. Then, in the Middle Ages, it was believed that human blood could deteriorate. It can become bad, and this bad blood needs to be released. The phenomenon was very common. In France, more than 30 million leeches were used per year, and there are 7 million in London a year, when the population was just a little more than 2 million. And Russia supplied about 70 million leeches a year to Europe. But then people were treated with mercury. Now we understand that this is nonsense, and there is no point in using leeches. Of course, some will object here. Indeed, in the 20th century, an anticoagulant effect was discovered in leeches. That is, due to hirudin, which is contained in leech saliva, blood clotting decreases. Accordingly, there is less likelihood of blood clots. But people didn't know this before. The essence was to release blood and no more. And leeches were used so as not to injure sensitive tender places with sharp objects. Mostly mucus, like the gums of the teeth. Therefore, where exactly leeches were used, dream up yourself. And besides, now there is a recombined hirudin if for some reason you need it. Plus, there are a lot of risks. For example, leeches can have different bacteria. At least inside them there should be bacteria that help digest blood. But there could be anything. And even though they are treated with antibiotics, not all strains can die. There are also excessive bleeding, allergic reactions, etc. And finally, leeches are disposable, and after the procedure they are destroyed, in order not to infect you with the HIV virus, for example, from a previous patient maybe. However, if they want to save money on you, then you will not know that this leech has already been on someone. We continue the topic of interesting nutrition. This is Eunis aphroditeis, or bobbit worm. The length is a couple of meters, buries himself in the sand with his whole long body and sits, wiggles his mustache, waiting for someone to swim by. And when someone swims by, they grab the victim with their claws, which can break the fish in half. About the fact that there are a lot of worms. Here's an example called Osedax. They were opened relatively recently, only in 2002. The thing is that they live at the depth of thousands of meters, and in size they reach only 4 centimeters, inconspicuous and very deep. And perhaps they would not have been noticed if the researchers had not looked at what Osedax eat on the bones of whales. males. In general, it doesn't matter to them whose bones to eat, and by and large, they don't really care about the bones. They need lipids that are contained in their bones. But here is the bad luck. You need nutrition, but you don't have a mouth. The Osedax have neither a mouth nor a stomach. They are not able to digest food. The bacteria that leave Osedax in these root-like processes will come to the rescue again. They break down fats, and worms already absorb nutrition. In this way, they resemble giant tube worms, again such a symbiosis. They even have a similar red feathers on top, performing the function of gills, and from below a root-like structure, which they are attached to the bones. Moreover, in order to thoroughly attach, special enzymes are released from there, which provoke erosion in the bone, and a hole is formed in which the worm has conveniently settled. I think the way I tell it sounds innocent enough, although in fact it is not the most pleasant sight. The bones are dotted with hundreds of individuals, and it seems that the bone is simply overgrown with some algae. However, such a number is not surprising. Female Osedax give birth to hundreds of eggs, and this is not surprising. Bones at the bottom are not so common, and everything needs to be done to preserve the population. Another interesting thing, scientists were initially surprised that they only come across females. It turned out that, approximately like anglerfish, these individuals have extreme sexual dimorphism. In fact, females carry males by the hundreds in tubes surrounding her body. In size, males don't reach even a millimeter. However, about 10 years ago, scientists discovered a new species of Osedax, in which males are much larger than their other species, and they even eat bones on their own. However, they don't move well, so in order to mate, they need the female to notice the male. To do this, they do literally the impossible and stretch 10 times. Which is pretty funny. It's easier to stretch 10 times than to learn how to move. The topic of nutrition is very important to me. However, it's time to talk about well-known earthworms. In fact, they are distributed all over the world, and they have been living for 500 million years, all because they are not picky about food and are able to adapt. They eat everything in a row, the simplest microorganisms, any organic matter, fungi and plants. The only thing they don't really like is frost. But even here they can get deeper in the ground and build a shelter for themselves. They insulate it with pieces of leaves or their waste. There they curl up and sleep. An earthworm can overwinter about 10 times. They live long enough. Earthworms breathe through the skin, and their enzyme-rich mucus helps them in this. Therefore, these worms cannot dry out. After all, oxygen dissolves in mucus and then is absorbed through the surface of the body. In short, mucus is simply necessary to breathe. Hot, dry weather is also undesirable for them, as is cold. Therefore, on dry days, they try to crawl deeper into the ground, where there is more moisture. Their body structure helps them crawl and tunnel. Firstly, the slime allows you to slide underground. Secondly, shrinking. It becomes thicker, which helps to push the stroke. And the third tool is their omnivore. If the soil is dense, the earthworm simply eats it, at the same time making its way. Another danger for them is the opposite. When there is too much moisture. Surely you have noticed that after the rain outside the city, a lot of worms appear on the street. This happens when the water begins to fill their passages and they escape by crawling out, so as not to suffocate. So show respect to the earthworms lying on the asphalt after the rain. They just want to live. Another danger for them is man, starting from various experiments like what happens if we cut it, ending with the global intervention in nature. Yes, surely everyone knows about this myth that if you cut a worm when it's two halves, will crawl like two separate individuals. Yes, it works with some kind of worms, as I mentioned about hammerhead, but it won't work with earthworms. If you cut the worm, leaving it with the head part, then it will probably be able to grow a new tail and survive. However, the tail will not be able to grow a new head for itself, because they can grow new nerve ganglia in their head and new mouth. As a result, the tail dies from lack of nutrition. Speaking of earthworms, it's impossible not to mention their contribution to the ecosystem. Charles Darwin also admired this. He devoted several works to earthworms. The fact is that, by proceeding food, earthworms secrete coprolite, which contains bacteria useful for soil fertility. In addition, worms reduce soil acidity. This is due to calcium carbonate on its mucus, which it lubricates the soil with. Thirdly, the kilometer-long passages that he digs allow moisture and oxygen to get better to the roots of plants, and this is also good. Therefore, in places where earthworms are threatened by something, where birds eat them, where the same hammerhead worms crawl, where somebody intervenes with the toxic chemical treatment, the soil becomes less fertile. And this contribution is so huge that without banal earthworms, our nature could be radically different. These are useful and harmless worms, but you're used to them. And what if you go to Australia? Here, on relatively small area, only about 40,000 hectares, around the Bass River in the south of Gippsland, megascalides live, or giant Gippsland earthworm. They also belong to the subgroup of earthworms, but unlike the usual ones, they reach up to 3 meters in length, with a thickness about a finger. They live in moist soil, not far from the river, and very rarely crawl to the surface, so you don't have to see them often. But you can hear, because in some places the number of adults reaches 10 per square meter. They feed on the roots and remains of plants. In search of food, worms get closer to the surface of the earth. And in case of danger, they quickly return to their burrows, going to the depth of 1–2.5 meters, which creates a characteristic noise in moist soil. Like other earthworms, giant Gippsland earthworm is okay with regeneration, and if they lose a body part, they are able to restore what is missing, except for the head, of course. But if the chopped parts are connected, they will grow together again, even if you substitute half from another worm. But by the way, this is not the biggest earthworm. South Africa takes the championship from Australia. The giant Microhatus rapi lives here, or African giant earthworm. Its average length is 1.5 meters, but it can reach 6 meters with a weight of 1.5 kilograms. You can see them only a few times a year, during heavy rains, when they are on the surface. The reason is still the same. When the earth is soaked with water, worms simply have nothing to breathe. Surprisingly, this often kills them. After all, if the bright sun abruptly comes to replace the downpour, they simply don't have time to hide from it and die under the scorching sun. I didn't know where to put it in the topic of unusual nutrition or the longest worms, but the name decided for me. Linnaeus longissimus reached the most fantastic use of regenerativity ability. During periods of lack of food and hunger, he eats himself from the other end, literally Ouroboros, and when he finds a normal meal, the eaten part completely grows back. By the way, this Linnaeus longissimus is also longest animal in the world, because its length in a stretched state can reach about 60 meters. It's like a width of a football field or like 20 floors, and this is with a thickness of only a centimeter. As for me, it's a pretty nasty looking creature. Plus, it's predator, because it feeds on smaller worms and crustaceans. In addition, he must be constantly on the move, because he doesn't have a heart, and the muscles of the whole body perform the function of the pump. Linnaeus longissimus lives in the coastal waters of northern Europe, in the strip from the UK to the Baltic Sea. So we have already listed a bunch of worms, and it seems to me that after such a list, somehow you stop feeling fear of them. After all, you understand how they are arranged, and that among all these thousands of species, there are practically no poisonous ones. There are only a few exceptions. For example, Blizeridae belong to the type of Podocate. They use poison to catch smaller ocean creatures, but this poison is not common. So I probably should have started with the fact that these are worms with copper teeth. I think it's a great introduction. Like what? A worm with teeth? A worm with copper teeth? Which are located on a separate proboscis, which straightens up at the moment of the bite. Probably, by the way, it's copper that makes worms even more toxic. When the worm bites the victim and injects poison, it's oxidized by combining with copper, which enchants the effect of the poison. There is a kind of chemical catalyst. Plus, his teeth are very strong. If you are interested in the size of such an instance, up to 40 centimeters. Although even such a creature, it would not be scary to meet a person. Well, more precisely, it's not dangerous. It can bite and writes that it is even painful, but not fatal.
Хорошая настойка будет. Сейчас только червей копаем.
Well, I left one more poisonous one for last. I like him the most in our selection today. Remember Linnaeus the Longissimus? This pile of worms, which is actually one worm? It belongs to the Nemertea type, and he has a close relative from the same subclass, which is famous for its other feature, namely this very proboscis. Meet Gorgonorhynchus repens. This is really a monster from science fiction movies, and now you will understand why. The size of this worm is only about 5 centimeters, orange in color, not outstanding in appearance, if not for a special way of hunting and self-defense. This creature, like many representatives of its species, has a cavity with liquid next to its mouth. When its walls contract, the pressure causes the fluid to rush into the proboscis, consisting of very elastic muscle tissue. It can stretch 30 times and then came back together. But specifically in this worm, the proboscis is a densely branching structure. It looks like webs or vines. Creepy. It's generally believed that in this way he captures his prey and pulls it into his mouth, because he is a predator and feeds on smaller worms and mollusks. It lives in the shallow waters of the Pacific Ocean, so to see such a curiosity alive, you will have to get to Australia again. Now we can assume that you have seen everything. Although no. We haven't talked about parasites yet, but this is for the next time. Therefore, let's summarize. Worms, harmless guys, useful for the soil, not poisonous, people eat them. Why then are they so unpleasant to us? There are several reasons. Firstly, associations work here. It's enough to see the process of eating a bunch of worms of some dead animal, or hear about cadaver worms, and the subconscious mind fixes this connection of worms with death or decay. Like it or not, we are organic. Bacteria and worms feed on us after death. And here again, worms are not necessarily involved. You all know about maggots. There are a lot of videos on YouTube with them, for how much they will eat a burger, pizza and anything else. But they're not worms. These are fly larvae, if you didn't know. Well, secondly, it can be called an evolutionary mechanism. Those who preferred to avoid worms survived better. Let's say food spoiled by worms could cause poisoning, possibly fatal. Plus, as I said, parasites. We listed a bunch of worms today, but I told you that there are tens of thousands of them, and unfortunately 70–80% of them are parasites. You are cooking a fish and there is a worm inside it. Is it worth eating it? There is already something like a genetic memory, a reflex. Parasites are evil, that you need to stay away from. And since there are more parasites, there are just a lot of interesting stories with them, which we will definitely tell you about next time. Tap the bell so not to miss it. Don't forget to set receive all notifications, not random ones. Share this video with your friends. Any of your help in promoting my beginner channel will be invaluable. Bye!